Good morning, ma'am.
Good morning, everyone.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning, everyone. Mute yourselves till I start the class.
Good morning, ma'am.
Good morning, ma'am.
Let's wait for 1 more minute and then I'll start the class. Okay, I'm going to start the class. Okay.
Okay, ma'am.
Yes, ma'am.
One sec. Okay, so we were doing interference, right? So the types of interference, the first type is division of wavefront. So you have all studied Young's double slit experiment in your 12th class, right?
Yes.
So what's
Yes,
Young's
ma'am.
double slit? So there is a source of light, let's say S. So the light is divided into two further beams through slits S1 and S2, and then the interference pattern is studied or analyzed on a screen. So this is the Young's double slit experimental arrangement, right? So what happens is the primary wavefront from this source S is divided into secondary wavefront through slits S1 and S2. These secondary wavefronts, they are coherent to each other because they are obtained from the primary wavefront, from a single wavefront. Their origin is same. That is why they are coherent to each other, and we can study the interference between these two wavefronts. So that is why it is the type of interference. This is called bidivision of wavefront. You understand why it is called division of wavefront? Because the primary wavefront from source S is divided into two further paths from slit S1 and S2. The same wavefront is divided into two further wavefronts. That is why it is called division of wavefront. So one example of such interference is Young's double slit experiment. Other two examples are Fresnel's biprism experiment and Lloyd's mirror experiment. Okay. And the other type of interference is by division of amplitude. You will study this type in your first semester course. So what happens in division of amplitude? See, this is a soap film. It means it is another medium, different medium. Let's say refractive index of this medium is N2. Above this soap film, there is air, refractive index of which, let's say, is N1. And below this soap film also, the refractive index of this air is N1. So what happens is a ray of light is incident on the interface between two mediums, which in this case is air and soap film. So when the ray of light is incident, at the interface, it is partially reflected back and partially refracted into the medium. This the ray which is refracted into the medium in the soap film, when it is incident on the second interface between soap film and the air, it is similarly undergo partially reflection and partial refraction into the medium. Again, this ray number, let's say this is ray number 1. At the interface at this point, let it denote this point. Let us denote this point by point P. At point P, this ray number 1 undergoes partial reflection and partial refraction. The partially refracted ray, let us denote it by R1. And partially refracted ray, let us denote this ray by R1, capital R. Then this ray capital R1, when it strikes the interface, second interface between soap film and air at point, let's say this point Q, it again undergoes partial refraction and partial refraction. Partial reflected ray, let's denote this ray by R2, and partially refracted ray, let's denote this ray by R2. Again, this ray R2 will go back into the medium and strike the interface between air and soap film. And at this point, let's denote this point by R. It again undergoes partial refraction and partial reflection. I have not shown the partially refracted ray. Reflected ray, I've only shown the partially refracted ray. Let's denote this ray by R3. So you can see in this medium N1, there are two rays, which rays R1 and R3.
मैम वॉइस नहीं आ रही है आपकी।
मैम वॉइस नहीं आ रही।
स्क्रीन भी फ्रीज हो गया।
हेलो मैम।
मैम वॉइस नहीं आ
अफरोज अंसारी अपना माइक बंद करो यार।
बंद है भाई, माइक बंद है।
अच्छा शिवम निषाद का चालू है।
मानस पांडे हमारा माइक ऑन नहीं है।
लड़ाई होगी भाई, लड़ाई होगी।
Yeah, sorry, there was network problem. Am I audible?
यस मैम।
यस मैम।
यस मैम।
So I'm going to share my screen.
यस मैम।
So tell me where I was.
फिर से क्या मैम?
फिर फ्रीज हो गया यार।
मैम आपकी स्क्रीन नहीं दिख रही है।
शिवम भाई क्या हो रहा है यार।
अरे यार मानस कुछ नहीं हो रहा है। नाश्ता हो रहा है इस समय। मैम कहाँ चली गई भाई?
Yeah, there was again network problem. I hope it won't occur again. So I'm going to share my screen. Okay, so I'll start from the beginning. So there is two types of interference. One is by division of, am I audible now?
Yes, ma'am.
Okay,
Yes,
by
ma'am.
Yes,
division
ma'am.
of wavefront. So you have studied one such example by division of wavefront, which was,
Double slit
what was the
experiment.
Young's double
YD.
slit experiment? Yeah, Young's double slit. And the second type of interference is by division of amplitude. You understand why it is called division of wavefront, because the same wavefront is divided into two portions. Now in division of amplitude, what will happen is, by division of amplitude, we will have two mediums, medium 1, medium 2. It can be any medium, right? So medium 1, medium 2. So there is interface between these two mediums. This is the interface. When a ray of light strikes on the interface, it will be partially reflected back and partially refracted into the medium. As the same ray is partially reflected and refracted, so its amplitude is divided. That is why it is called by division of amplitude. Now the division amplitude of the wave is divided into two. The same ray which is refracted into the medium, when it strikes this interface, it again undergoes partial reflection and partial refraction. Now this ray, I'll represent it with different colors. This ray, when it strikes the interface again between the two mediums, it similarly undergoes partial. Now if it is reflected into the medium, it will go back like this, and after refraction, it will go like parallel to the above ray. Parallel to this ray, like this. These two rays are parallel to each other, but if we place a lens, they can superimpose on each other. After superposition, they will produce interference, just like Young's double slit experiment, where two slits, S1 and S2, when rays from these two superimpose on each other, we get interference pattern. Similarly, when ray number, I'll denote this ray by R1 and R2, when these two rays R1 and R2, they superimpose on each other, we will get interference pattern. And again, if we place the screen here, we can analyze that interference pattern. It is called division of amplitude because the rays, after reflection and refraction, its amplitude is divided into two portions. Clear?
दोनों ब्लू रे पैरेलल नहीं ना होगा?
Parallel hoga. That's why I'm saying we can place a lens. Then they can superimpose on each other.
Ma'am, but they are intersecting.
Ma'am,
But they are intersecting. Yeah, they superimpose. What is the principle of superposition? What is superimposition? That at one point there are two rays, right? This is a superposition. Na? Principle of superposition, what does it state? That at any point, if there are two rays or waves which are coming, the net resultant of the two waves is the sum of individual waves. Y1 and Y2. Superposition means intersection kind of thing.
अगर intersect कर रहा है तो parallel नहीं हो सकता है.
They're not intersecting, they're parallel rays. If we place a converging lens like this, now clear? We can place the screen at the focus of the lens. Clear?
Ma'am,
These two are parallel rays.
ma'am, red ray and blue ray are parallel, or both blue rays are parallel?
Your voice is not clear, first of all.
मैम रेड रे और ब्लू रे दोनों और ब्लू रे पैरेलल है या फिर दोनों ब्लू रे पैरेलल है?
Okay, I'll draw it with proper color coding. Okay, so these are the interface. First, red ray is coming. Proper color coding I'll draw it with. This red ray is coming. It is partially reflected into the medium. I'll denote the reflected rays with the red color and refracted rays with blue color. Okay, again now this is reflected back. If you are confusing it with red or blue color, ultimately these are rays, right? These are light rays.
Yes.
Whether it comes from reflection or refraction, it is ultimately the light rays. And if they are going parallel to each other, they are parallel to each other. If we place a converging lens over here, these will get focused at the focal point of lens. We can place a screen at a distance equal to focal length of the lens from the lens, right?
Yes, ma'am.
So these rays can be made to superimpose on each other, and here they will produce interference pattern. And that interference is called division by amplitude, because the incident ray, ray number 1, when it goes partial refractions or refractions, it divides, amplitude is divided into the number of portion. It goes multiple reflections and refractions. At this point, when there is partial refraction and refraction, the amplitude is divided into the two portions. So this
Yes,
type of interference is called reflection, interference by reflection. By reflection, why so? Because if this is medium 1 and this is medium 2, you can see these look like they are reflected from the interface. Right? So this is called the reflected component of the interference. And if we study, see at this point, this ray undergoes reflection as well as refraction. Similarly, at this point, this ray undergoes refraction and reflection. See, there are multiple reflections and refractions. So it will reflect into the medium. As I told you, we can place a lens and study the interference pattern. Similarly, here also these rays are parallel to each other. We can place a converging lens. These rays can be made to meet at the focal point of the lens, and we can place a screen over here. Similarly, these rays can also produce an interference pattern. And in this case of interference, it is called by transmission or transmitted component. Transmitted component of interference. Clear? Because
Yes, ma'am.
this portion, these are reflected rays, and this portion, it is transmitted rays. So it is called interference by reflection. This is called interference by transmission. All of this you will study in your first semester course in detail. I've just given you an overview of this. So you will study in detail of all of these things. So the first example is of bidivision of amplitude is color in soap bubbles and oil film. All of you must have seen soap bubbles, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So in sunlight, that bubble displays color also, right?
Yes, ma'am.
Yes, ma'am.
Multiple colors. So the color in that soap bubble, it comes because of interference. How this comes, you will study in your first semester. And similarly, oil film spread over the surface of water. Have you realized this? If
Yes,
you
yes,
spread
ma'am.
an oil drop over the surface of water and the thickness of oil drop is very less, so then also
ma'am.
that film displays multiple colors. And
Yes,
the
ma'am.
second example is Newton's ring. This is very important topic in your first semester, Newton's ring experiment and Michelson-Morley experiment. All these three are very important topics of your first semester course. You will study in detail all of these three examples. Now you can write by division of amplitude on your notebooks. Just example, what are the three examples and what is the method in brief you can write. What are the types of interference in the corresponding examples?
मैम इंटरफेरेंस ऑफ रिफ्लेक्शन को इंटरफेरेंस बाय ट्रांसमिशन कहा था आपने. मैम
बोलो.
मैम इंटरफेरेंस ऑफ रिफ्लेक्शन को इंटरफेरेंस बाय ट्रांसमिशन कहा था आपने.
नहीं नहीं, आई एम सेइंग इंटरफेरेंस बाय रिफ्लेक्शन और ट्रांसमिशन लिखो मत. आई वाज जस्ट सेइंग कि ये जो कंपोनेंट्स हैं हियर, this is called reflected component and these are called transmitted component. You will study this in detail. This is transmitted component or interference by transmission, and this is interference by reflection, this one, or reflected component. Have you noted this down?
Yes, ma'am.
Everyone, should I move to next topic?
Yes, ma'am.
Okay, so we were talking about by division of wavefront. So what is wavefront? What do you mean by
locus
wavefront?
at those points locus at those point जिसका फेस सेम हो.
Locus of those points. Right?
Yes ma'am.
Okay, so what is wavefront? Suppose in a medium, a number of waves are going, let's say like this. I'll draw it more efficiently like this. These are in synchronization with each other. So at these points, actually at all of these points, the phase of all the waves is same. So this is called wavefront. How many types of wavefronts are there? So it is the set of, first of all, what is the definition? It is the set of all points साथ साथ लिखना है इसका. Set of all points having the same phase in a medium. Having the same phase in a medium. This is how you define wavefront. Now tell me what are the types of wavefront.
Plane wavefront, circular wavefront,
Yes,
cylindrical wave.
circular wavefront. Okay,
No, spherical.
spherical. Then
Spherical, plane, or
Cylindrical.
cylindrical.
yes. Okay. So we will come to one by one each wavefront. First one is, let's say, spherical wavefront. So how it looks like?
Point size.
No, I'm asking how spherical wavefront looks like. What is the shape of spherical wavefront?
And it's of a sphere, but
Yeah, the shape is
Indeed.
spherical. Then is the name is clearly telling us, right? The shape is spherical. So it looks like something like this. Spherical, you can imagine. Now I'm drawing in 2 dimensions. In 3 dimensions, it is a sphere. So how it is created? What is the source of
a
light?
point size. So
Yes, a point size
unlike
source.
sun.
Yes. So it is created by point source. Example?
Sun.
Bulb.
Yeah,
Sun.
sun, bulb, yes.
Balloon.
All of this emits light in all the directions, in 3 directions. You can imagine, you can clearly see it from here that at the surface of sphere, the phase of all the waves which are spread out from this point source is same. So this is the locus. This spherical surface is the locus of all points which are having the same phase on the waves which are spread out from this point source. Hence, in this case, the wavefront is spherical. Example is sunlight. Only if we consider the sun to be a point source, right? Sun has large dimensions, actually. Okay, the second one is, what is the second type of wavefront?
Plane wave.
Cylindrical.
Plane wavefront. So what is the shape of plane wavefront?
Triangle.
It's a plane surface.
Yes, ma'am.
So when does a wavefront will appear plane?
When rays are from infinity.
Yes, when the source is at large distance, very large distance, you say. Very large distance or at infinity. Can you obtain plane wavefront from spherical wavefront?
Yes.
Yes, ma'am.
How?
Yes, ma'am.
If the point charge
Ma'am,
is at infinite distance, yes. The same spherical wavefront, its small portion will appear to be plane when the point charge is at infinite distance. So, for example,
Car
point
headlights.
charge. Yeah, if this point source is at infinite distance. Sunlight, which we gave example in case of spherical wavefront, sun is at very large distance from us, right?
Yes, ma'am.
Yeah. So same example can be used over here. Point charge at infinity, then spherical wavefront. will appear plane. You can note
Ma'am,
this
how
down.
sunlight,
Hmm.
ma'am, how sunlight is a spherical wavefront as well as
See,
wavefront, plane
sun,
wavefront?
yeah. If we are near the sun, imagine the wavefront it emits, the sun, the wavefront which sun emits is spherical, right? If we are near to the sun, the same wavefront, spherical wavefront at Earth, because sun is at huge distance from us, the same spherical wavefront, this is suppose sun and this is Earth. Now sun is emitting light in all directions, and if we are near to sun, it will emit spherical wavefronts in all directions like this. Now at the same spherical wavefront at Earth, because we are at large distance from the sun, its small portion will appear plane to us. That is what I'm writing over here. For example, point charge at infinity, then spherical wavefront will appear plane. Clear now?
Yes, ma'am.
Will appear plane.
Ma'am,
Note this down also. Yes.
when we throw a stone in water, is it a spherical wavefront?
Yes. Yeah. But because it is in 2 dimensions, that appears circular in shape. Over the surface of water, the waves which are appearing, it appears circular wavefront because it is in 2 dimensions, right?
But ma'am, I think it's not in 2 dimension, it's in 3 dimension because underwater it's also appear.
But it appears on the surface of water.
Ripples are formed on the surface.
On the surface of water. It's not in 3 dimension at least. Is there any
If
doubt? Still
observer
any
is
doubt? Yeah, if the observer is underwater, then the situation will be different. Yes, of course. But when we are observing on the like from the land, we are observing the when we are throwing a stone on the surface of water, we are observing it in the 2 dimension only.
yes, ma'am.
Yes, ma'am.
Write this down. So if the rays are coming from infinity, the wavefront is plane wavefront, like this. Let me know when you finish writing this down. Okay?
Noted, ma'am.
Okay. So should I move to next third type?
Yes, ma'am.
Yes, ma'am.
So what is the third type which is left?
Cylindrical wavefront.
Cylindrical wavefront. What is the origin of cylindrical wavefront? What is the origin? Third type is cylindrical wavefront. Example?
Tube light.
Ma'am, tube light.
Yeah,
And linear source.
linear source. Yes, tube light is very good example. It's created by a linear light source. Example, slit or tubelight. So if we consider a linear light source, as it will emit light in all directions. So first of all, there is a circular symmetry. If we consider only this point over the line source, so there is a circular symmetry. So all the points on this circle will have same phase. All the waves on this, which are lying on this circle, will have same phase. As we move along this linear source, different points, so there will be linear symmetry also. So all the set of all points with same phase lies on a cylindrical surface. So this is cylindrical wave. So there is an announcement for you also. Have you got a link for MOOCs courses?
Yes, ma'am. No, ma'am.
Yeah. No?
No, ma'am.
Any of you has got or not? Yes or no? No one has got.
Ma'am, yeah.
No, ma'am.
Okay, so you will
Yes,
get
ma'am.
you will get it if you have not got it now till yet. So there is a link you will get for your MOOCs course. You click on that link and then you fill your email ID, official email ID and password, and there will be a screen and there will be some steps you will be guided to. You have to complete 2 courses before coming back to college. Okay?
Some personal email ID or school email ID.
No, it's official email ID and password. Yes.
मैसेज आया भी है मेरे आज अभी आया था
हम just अभी आया Teams पे और
Okay,
link.
fine. After the class, you click on the link. Okay, not now. After the class, click on the link, fill your official email ID and password, and then there will be steps. You will get to know how to follow those steps. You will be like have to complete 2 courses before coming back to college. Okay, it's necessary for all. Okay, so you check the link after the class. So coming back to this, have you noted this down?
Ma'am,
Yes.
ma'am, during the interference by division of wavefront,
Mhm.
when the light passes, when the wavefront passes through the slit,
Yes.
then we draw spherical wavefront. So is it cylindrical or spherical?
It is spherical wavefront. Because see, you are confusing it with slit. We are considering single points over there. See, the thing is, if there is slit like this, S1. We are only interested in the rays which go in this direction, right?
Yes, ma'am.
Which will be able to come to the screen. So if we consider a single points, you will your doubt will be clear when we will discuss diffraction. Or just in next slide, I'll discuss this. When we calculate the path difference, I'll discuss this doubt of yours. How we consider points in the slit and not a linear slit as a whole. When we consider points in the slit, then it will be like point charge, point source. Here it is point source, not point charge. So when we consider slit to be made up of small points, so this point source will be a source of spherical wavefront. And why we are considering these points and not the whole slit, I'll discuss in the next slide. Okay?
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
So should I move to next one?
Yes,
Yes, ma'am.
So this is Young's double slit experiment. See here it is considering to be spherical wavefronts. This is the point source S1, S. These are slits S1 and S2 where crest meets the crest. we get a bright fringe, and where crest meets the trough, we get a dark fringe. See here, I was talking about. Here I'll explain. So these are the two slits. Rays are coming from the two slits. We are only considering rays which are going in the direction theta in general. Okay. So why we are considering point source? See, slit has some dimensions. This S1 slit and S2 slit. This region is opaque, right? This region is opaque. There are slit S1 and S2, and it has some dimensions. So this point give rise to some rays which will interfere with the rays from this point. So what we consider is superposition of rays which comes from the corresponding points of the slit. So if the center of slit is this point, let me denote with red color. See, this is the center of slit S1 and this is center of slit S2. So what we consider is the rays from these two points. We made to superimpose these rays. So different points, slit S1 starts from here. So there will be some point and there will be some rays. Then there is slit S2, it starts from here. The rays coming from here. Second point is this, the ray is coming over here. Similarly, second ray comes from here. So we are considering the rays from the corresponding points of the slit. You can imagine now, otherwise what will happen? The rays can come from slit S1, it has a finite dimension. So there will be number of rays coming. Why we are considering only two rays then? So to simplify our discussion, what we assume is we only consider two rays which are coming from the corresponding points of the slit. Am I clear to you?
Yes, ma'am.
Yes,
We
ma'am.
only consider here two rays, but actually slit S1 is a source of large number of rays. To simplify our discussion, why we are only considering the path difference between two rays, what we do is to simplify our discussion or calculation, we consider that we are superimposing two rays which are coming from the corresponding points of the slit. Similarly, as I have drawn purple or red point, similarly, next point, let's say it gives rise to this ray, blue. Similarly here. So we superimpose these two blue rays just for the calculation purpose. Clear?
Yes, ma'am.
Ayush, I think it was Ayush doubt. Whose doubt was this?
Abhinav.
Okay,
Abhinav,
Abhinav, now
I meant.
is it clear now?
Yes, ma'am.
If you still have this doubt now, when we will discuss in diffraction, then I think your doubt will be clearly solved by that time. If there is still
Okay,
some
ma'am.
doubt is left. Okay, so
Okay, ma'am.
Similarly, we are considering these two rays which are coming from the center of slits S1 and S2. We are considering only two rays which are going in this direction. In fact, there are large number of rays which are going in this direction theta. Okay, so we want to see what is the path difference between these two rays. After this point, these two rays will cover the same path. So the path difference is given by this length. Let's denote it with delta. So how this delta will be calculated? In this triangle, this angle is also theta. How? Okay, so I'll draw it here.
With the help of
This is the first
trigonometry.
ray. This is first ray. This is second ray. So we draw a perpendicular. Let's say A N. Perpendicular on the ray number 2. This is first ray. This is second ray. And this is angle theta. If this is angle theta, this is perpendicular, right? This is also angle theta. If this angle is theta, this blue one, what will be this red angle?
Ma'am, 90 minus theta.
Yeah, this one will be 90 minus theta. So if this is 90 minus theta, this angle is right angle, which means it is 90 degree. We have to find this angle. Let's denote this angle with x. As sum of angles of a triangle is 180. So angle x is equal to 90, 90, 180. This will be cancelled out. X will come out to be theta. So this angle is also theta. Clear?
Yes, ma'am.
Yes, ma'am.
Yeah. So now this triangle A, B, C. Using sine theta expression, we can calculate the path difference delta between rays 1 and 2. Sine theta is equal to, this is perpendicular. Perpendicular upon hypotenuse. Perpendicular is this delta. What is the hypotenuse? The distance between the
D,
slits.
small d.
Yes, D. So that's how delta, which is path difference between the two rays 1 and 2, is equal to D sine theta. So this is the path difference between rays 1 and 2. For bright fringes, what was the condition for constructive interference? Path difference should be equal to n lambda. Yesterday we discussed this. N is equal to integer and takes integral values. And for dark fringes, path difference delta should be equal to 2n plus minus 1 lambda by 2. N is equal to 0, 1, 2, 3. If you take 2 common, then it will be n plus half lambda. This and this expression is same. So these are the condition for bright and dark fringes. So you understand, we are only considering two rays, calculating its path difference. For bright fringe, we are putting the condition for constructive interference. For dark fringe, we are putting the condition of destructive interference. So why we are only considering two rays? Similarly, we've considered all the points of the slit, like I explained you previously. So each point will give rise to a ray, and these rays will be considered for superposition. Similarly, here, just like we have considered the rays coming from the center of slits, we can consider the rays coming from different points of the slit S1 and S2. And these rays, which rays are considered to be superimposed on each other, which are coming from the corresponding points of the slit S1 and S2. Here, these rays are coming from the center of slit S1 and S2. You note this down, all these conditions.
Ma'am,
Yes.
can you explain again the derivation of path difference?
Okay. So till now, is it clear that this angle is theta, or should I explain it again? This angle.
Yes, ma'am, उसी को explain करना है.
Okay, fine. See, so this angle is theta, right? We are considering the ray which is inclined at an angle theta with the horizontal. So this red angle is theta. This is 90-degree angle. So if this is theta, what will be this angle? This remaining
90
angle.
minus theta.
90 minus theta. So we are interested in this angle. Let it denote by this by angle x. So we want to know what x is. We know in a triangle A, B, and C, sum of angle is 180 degree. So x plus this angle is 90 minus theta plus this is right angle triangle. So this angle is 90 degree. This is equal to 180 degree. 90 plus 90 will be 180. So this will be cancelled on both sides. Hence x is equal to theta. So this angle is theta now. So we are having a triangle like this. This is triangle A, B, and C. This angle is 90 degree. This angle is 90 minus theta and this is angle theta. So theta के opposite क्या होता है? Perpendicular होता है. So this is perpendicular and this is hypotenuse. Perpendicular is what? Delta, path difference between rays 1 and 2. This quantity we want to find now. So this is delta, path difference. And hypotenuse is what? Distance between the slit S1 and S2, which is D. As we know, sine theta is equal to perpendicular upon hypotenuse. So sine theta is equal to what is perpendicular? Delta, that is path difference between the rays, upon what is hypotenuse? D. So cross multiply, you get D, delta is equal to D sine theta. Now it is clear?
Yes, ma'am. Thank you.
Okay, you all note this down.
मैम फिगर को भी नोट करना है.
बना लो. यस, ऐसा करो, सेकंड वाली फिगर बना लो. दिस वन ओनली. I'll clean this up.
मैम ये कोर्स पेड कोर्स है क्या?
क्या?
ये जो कोर्स मिल रहा है ये पेड कोर्स है
नहीं
क्या?
पेड नहीं होगा. नहीं. So you are looking at that link now. I asked you to look at that link after the class.
यस मैम.
If we have
मैम
any
अभी तो
doubt,
आया नहीं है इनका मैसेज.
okay, आ जाएगा.
अच्छा,
You note this down.
मेरे पे तो नहीं आया अभी.
You can discuss this after the class, okay? Note कर लो, then we'll continue in tomorrow's class.
हो गया मैम.
Okay. So give me a minute. Okay, thank you all. We'll
Thank you, ma'am.
class tomorrow.
Thank you, ma'am.
थैंक यू मैम.
Thank you, ma'am.